Hello everyone and welcome back here on CodeForces. We're solving today a Division 4 round. Check out my channel for beginner and advanced tutorials on competitive programming and other things, including electronics. So today I'm using as always CPH-Judge. Many people ask what extension I'm using. It's CPH-Judge. I'll just zoom in here, maybe it will be better. We will try to solve all of the problems. I think it's fairly easy round. So we'll see. Slavic G organizes it, so the problem should be good. Yeah, that's it. So 10 seconds to the contest. If you have any questions, just leave them in the comments. And yeah, for this extension you need to have competitive companion extension as well installed in Chrome, so to just connect the browser to so the browser can send information to the extension. You'll see how it works. Okay, so he has a string having length 10. Maybe they only wants to know how many indices a string differs from the string CodeForces. So just easy. Just read the string. Have like some count here, and if s of I differs from the from this count plus. Wow. Okay. That should be the problem. So let's go B. You have binary array A of n elements. A binary array consists only of 0 and 1s. Blank segment of consecutive elements consisting only of zeros. Find the length of the longest blank segment. You can solve this problem in many ways. But what I will actually do is I will have like this array, or maybe you don't even need an array, you can just read the integers as you go, and then longest, and then current is 0 if x is 0, then current plus, else longest is max of longest and current to 0. Now one more thing you have to check at the end as well. This sounds CodeForces is slow. There are many people solving these problems right now, so that's why it's actually slow. Over 25,000 or something. So wants to become okay. For that he needs to acquire a certain set of skills. More precisely, he has 2 skills he needs to acquire. Victor has n books. Reading m book I takes mi minutes, and will give him some. Possibly none of the required 2 skills represented by a binary string of length 2. Okay, what's the minimum time required to acquire all of these 2 skills? Just easy problem as well. So I will just have a vector where I will have like a pair, and then I will have like a string or something like this. Let's say this is A. I will read them, and then one time is like I'll say maximum time. And now if a dot second is like this string, which is like 1 1, then time is min time and a dot first. Another thing is I will have t1 to read the first problem, which is like max time, and t2 is also max time. I will divide them here by 10 or something, just so it doesn't overflow. And then else if ai second is this, I didn't even need to read a minimum factor, but whatever. Time 1 is minimum time 1, and else if ai second is this, then it's like time 2. And then we want to see out the minimum of, so here is like we say that thing is we say that this, okay, time is minimum of time and t1 plus t2, so we just maybe combine these two. And if time is, so like this, if time is bigger or equal than int max divided by like 20, c out minus 1, I'll see out time. This shouldn't overflow at all. Okay, let's go D. Take any, so n nuggets, take any problem, split it into 2, so that the resulting has twice as many gold nuggets as the other. So that one of the resulting, all piles have integer number of nuggets. Can you make a pile with exactly m gold nuggets with 0 or more? Operations. So this is what if it's not divis? Okay, if it's a integer, if it's this, it's fine. If it's not divisible, but if it's like a prime. So this is like 3 nuggets into 1, yes, but 5. So if it's like if you can't make this, if like it's not divisible by 3, then like you cannot do it. Are they all divisible by 3? So if m is bigger than n, of course we cannot do it. Okay, now Now if n is divisible by 3, I can divide n. So is it like just yeah, so I can divide n, then the resulting pile. Yeah, so I will do this. It's like so if m is equal to n, then sure. If not, this has the n, right? And then while d is not empty, we are going to maybe just do q or something. Top is d.front, d.pop. If t is like m, wait, I can always divide it by so if it's like by 3, one pile has this prime without this prime, the other pile without this prime, but times 2. It adds 2 on the end of the prime. And then okay, so you don't need to simulate this. So what this operation does is like this prime. So this n is divisible by 3, then we get some like prime factorization, so some other number, t is equal n divided by 3. T2 is like 2 times n divided by 3. So we take this 3 here. So essentially what you want is like m. So what you want is to divide how many times does 3 occur in n, how many times does 2 occur in n, and how many times does 3 essentially the other primes don't really matter. So I will just do this. While n is divisible by 3, I will divide it by 3. Also, this is the same case as like 2. Now this is the same as m. I will do this as well. So m divides by 3, m plus plus, m plus plus. If n is not equal to m, then there's no way. But there is like the idea of now putting these here to the action. So in m, if they're equal, so there's like cases here. n is, if I have 3 to some power, then on m this power has to be smaller, right? So if m has bigger power of 3 than n, I can't do it. So if m3 bigger, then I can't do it. So just m3 bigger than n3, I can't do it. Also, okay, so now it's smaller or equal. Now then, this is the difference. The difference is how many we have in n3 and how many. Now the difference should be, if this difference is equal to the difference in, is like smaller or equal to the difference in m, in smaller or equal to the, so we can only add 2's to m. So I think something like this. Then this is yes. Otherwise it's not. It is differences. What is this fifth case? 0, 1, 2, 3, 4, 5, 4. So we have 2 2's here and 3 2's here. That difference should be bigger or equal to that difference. Okay, here is what? So 2, that the difference is like 0 here, and this is so if also m2 should be bigger or equal to m. Should be, if it's smaller, then it's not okay. Okay. I think they should pass, but I don't know, we'll see. The lakes. Let me just see the standings. Internal. Okay, is that like, is it, okay, it gets accepted. You're given n by grid A of the value AI represents the depth of the water. A lake is a set of cells such that each cell has AI greater than 0. There exists a path from any pair. The volume of the lake is the sum of the depths. Find the largest volume of a lake. So you just what you do, you can do breadth first search, let's say. And oops, I need tests. You could do breadth first search and just count out how many of these. So okay, I will just call it like this. I won't copy. It's faster. some. What am I doing? I just. This. I will go over all the 4 directions. If that direction is valid, and the matrix at the new direction is greater than 0 if it's not visited. Now I need valid function here. Okay, and now the answer here is answer max answer sum. So much long. Okay, passes. Let's submit. Okay, let's go F. Snowflake graph is generated from 2 integers x and y, both graders start with 1 vertex, connect x new vertices to the central vertex, connect y new vertices to each of the x vertices. So first like this, then okay. Just we got wrong answer on E. Wait, what? Define the largest volume of a lake in the grid. Okay, that's impossible. The largest volume of lake. Am I not seeing something? I mean, I don't understand. 4 direction, Y direction, dx. I'm baffled. It shouldn't even overflow. How is this wrong answer? Oh. I frankly don't see it. There exists a path between any pairs of cells in the lake by going up, down, left, or right any number of times without stepping. I'm confused. Is it something wrong? More negative integers. Oh, of course, if method ij0 okay, so what is f? Given that snowflake graph, determine the values of x and y. Okay. Do you have like okay, so first of all, there will be two sets of like different degrees, or actually multiple sets of different degrees, but only the leaves will have like degree 1 node, so we don't really care. So what are the n and m? So did it pass? Yes. Okay. N and m. So vector of degrees, only like degrees of each node. That's n. Then for each edge, I will just this, and then I will iterate over the degrees and say, okay, there are two sets of, so there are like map at this element plus plus, and then there are only like it the case always? Start with one central word, text connect. I think it's always the case. IT first. Minus 1. I think there should be always this case. Oh. Oh, so you have to, yeah, wait, so the degrees is, okay, so you can find like a leaf node. So you can go over all of if degrees of I. Oh yeah. If degrees of I is 1, then this is a leaf node, which means that like an edge to this node gets me so let's remember the edges as well. An edge to this node gets me to a node adjacency at E at 0 gets me I at 0 gets me to a, let's say, some V node, right? So Y is like degree of V. Y is degree of V, and then for all of the adjacency, at V, if the degree of VV is bigger than 1, then X is this. X is the degree of VV. Then break. So we don't even need map, I'll just X minus 1, Y minus 1. If I understood the problem correctly. Yo, no, not X minus 1. Because X is... Okay, let's go. Hits different G. Okay, how much time did we spend on these problems? 33 minutes, okay. Carnival game, there is huge pyramid of cans with these many rows numbered. If 9 square is hit initially, then all cans colored red in the picture above would fall. Okay. Okay. You throw a ball at a pyramid and hits single can with number n squared. This causes all to fall. What is the sum of the numbers on all cans that fall? This is sum of consecutive. It's not really sum of consecutive squares. It's so these are like consecutive thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For valid input, the answer will always fit in. Okay. Wait, how n is 10 to the 6? Okay, so after some point, all of these are falling. So like you could compute. I'm interested how many levels are there for. I'm interested in something. So n to the 6, how many levels are there? So I need some. There are this many levels times this many cases. Yeah, we can brute force them. So technically, so for each level, I wanna really quickly know what are these squares that will fall. So how do you oh, for each of this I can compute technically like the parents, and then just having like the leftmost and the rightmost parent. Just summing up like that. I mean, yeah, implementation is a little bit heavier task, but so I will have like this pre-computed somewhere. So the sum here, level So levels, and in each level we will compute the 0th level. I will compute from 1 I will start here. The sum here is from the sum plus 1 wait, what am I doing? My first level. Okay. Also, I need to offset this by levels dot pushback j plus some offset, which is what now? Sum times j plus some. Okay, this should be long levels at or that back is just fine. How this doesn't overflow? Yeah, it doesn't overflow. Alright, so we just want to say in which level, so for every integer n, so this if j plus sum is where that size, where j plus sum is equal to level minus 1 level dot bag dot size. Okay, then we just want to do So on the previous layer, it's like first we find where that is, level and location. Position is where I am. Also, I need to pre-compute how do I don't want to overflow something here. Will it overflow? It will possibly overflow. I have to be careful. Or just use maybe I could just use int 12080. How fast is this? This is very fast. Okay, so can I just print out just for you guys to see levels? Out the element in level, I will see out element. Oh yeah, not long I've overwritten. We are not doing level. We're not doing it proper. Level. Okay, it seems fine to me. Okay, I just crashed the judge here. Seems fine to me. So we find this position and while position, I'll say while true for now. I don't know what's my condition here. I will say, okay, the position, it seems to be so I'll say like this, the left position is now P and the right position is P. The left position will be P minus 1, the right position will be P. And now we want here, we want this like the sum. And now here I will have to have like prefixes here for each layer. There's probably a better way of computing this, but whatever. Prefix dot push back this plus levels dot back. Okay, and then what we want is okay, I will do this while levels is I think I have done while levels is bigger or equal than 0. So the sum here is prefix at r minus prefix at l minus 1, l minus 1, otherwise 0. This is the okay. What now? What? Oh, at my level here. That's my prefix. And then see out some. What is this now? Levels.back. B minus 1. There could be a way that like well, wait, am I getting here? No, something is. Oh yeah. This is bad code, but whatever. It should work. Okay, here. Of course, when L and R are not probably right. So this is what? This is 2, 2. So 2, 2 is what? $36. Is that 36? No. J plus N is 9, right? Two. So 0, 0, 0, 0, 1, 2, 1, 0, 1, okay. This is correct. It should be 3, 2. Oh yeah, 2, 2 is because it's 2 here, right? But the level is 3. 2. Yeah, minus, minus, and then this is like, this remains. Two, two, 1, 2, 0, 2, minus 1, 2. And also R is like minimum of R and prefix of L dot size minus 1. Come on, whatever, minimum function. 91. Overwritten that. 32, 77, 90, 91. 9 squared is not 32. Where the f... I don't know where the F do I get 32. $49, and then $49, and then this minus 49. 64. Something goes wrong. 32. The last is levels dot back dot size. Levels dot back. What the F is going on? 2, 2. It is not printing. Oh, it's not printing because, yeah. Prefix is not levels. Okay, now it works. Okay, now it works. Okay. Weird. Compilation error. Wait, what? Was not declared in the scope. Okay, do I need some other compiler or something? Okay, accepted. Okay, this took me a while to get. Sadly, the problem setter couldn't think of an interesting story. Given an array A of positive count number of non-empty subsequences for which the bitwise end of the elements in the subsequence has exactly k set bits in the bitwise representation. Bitwise end. Bitwise end is like if you're looking for k bits in the bitwise end, the thing is that you could the subsequence the other elements should be like sub elements like this. Wait, k is up to 6. Oh, okay, that's easy. Okay, now that's and a egg only goes to 63. Okay, that's okay. I thought my mind went like, wait, what convolutions? What? Wait, what? Okay, that's easy. So the trick is like, because 63, you could brute force. You could brute force. You could brute force for each of these. How many subsequences? So for each position, okay, let's say it like this. For each position, how many subsequences ending at that number exist? Which have subset. Which are subsets from that number. mean, that will work, right? Let me just add like fast input, so I just don't. But I think that DP should work. Not K, 64. So these are like 64 bits, and then we will say, but this is times 64. Will it work times 64? It shouldn't work. We need carefully to go through all of the bits which are. So there's this Goshpers hack here, where Goshpers hack this here thingy, where you kind of say we okay, so what we're gonna do is for this for which subsequence of elements has exactly k set bits in there. So the answer is we have this structure, so care about module here as well. Okay. Yes. The answer is the following: for each of the 64 this, if I and if built-in pop count of I is equal to k, then the answer is updated with this. Okay, now this here is I want the Goshpers hack from no, not the Goshpers hack. No. We want this sum of subsets. There is a hack that does this really sum of subsets, dynamic programming sum over subsets. This is hack that does this really quickly. So this goes over subset the function with inclusion exclusion principle. Do we want with inclusion exclusion? think so, no? I think we need to use this. Like the mask goes from this to like 64. And we say that no, let me just think about this. Yeah, so this k here, this 1 to the I, 1 to the n, right? Let's say 1 to the h, some like other number. This is I. This here, let's say this is like v, something else. So h is the logger, this here. So 1 to the what is 16 for 1 to the 6. Yes, so h is like 6. Const int h is like 6, right? Then we want to iterate v from 0 to 6. This way what we're doing is we iterate to 6 through all of these like sets, to all of these bits, and now dp of I of this is like dp of I of the mask without this bit. No, actually, like this should be the same array here. Now, technically, we don't want inclusion exclusion, right? No, technically, we don't want inclusion exclusion. Technically, we can just do this. No, we don't want inclusion exclusion here. So technically, this is dp of I, this is dp of I minus 1 without this bit, right? So we say dp of I here is like dp of I minus 1 without this bit. Is that correct though? So like here is this thing here is like we only want to, like we have some number here, we want to transfer everything, but for some mask yeah, yeah, no, we want to transfer. So my dip is this. So my dip is like this from 64. Let's see how I can. Yeah, for like this, I of u is dp of I minus u, right? If this is the case, dp of 0, yeah. So we can just start from dp of 1. dp of 0 and a of 0 is 1. Whenever ret that's the least for worries. So okay, so this is 1, and then what we do is we say, okay, we copy everything out, and we say that for each of this sub, so we have now AI, right? AI is going to copy out from each of the subsequences for AI, so like this. So this is what we're gonna do for each of these. If the mask and AI, I will copy out this. Also 0, no? No, it's like we want to if I take this element, for all of these elements that are here, if I take this element, yeah, so this is what we're going to do. Mask and AI plus mask, right? Like this. Should that be? Okay. If I take AI, if I have some mask and I take AI, then this is the case, right? First we start from 1. What's wrong here? Oh, you could end up anywhere, right? Maybe we need to sum up over all of these things here. Not quite. No, not quite, because like I can take not quite. I mean, why would I sign up when I'm copying out these here? I'm copying out every DP here. The mask and AI is so if I have like one bit here, here's this, then the end of this could be also here. Okay, let's see how the DP looks. How is it 32? 31? Count number of non-empty subsequences. How is it 32? 2 to the 5 is 30, right? Minus 1 is like the empty subsequence. So like technically, can I do this? Yeah, because they're all zeros. No, technically I can't do that. I can't do that because this has to be this, then well, the dp of I and a of I should be as well, right? That sounds about right. Okay, that passes. I'll just submit. Okay, gets accepted. So yeah, we're going to explain now every problem, how we solved it, and yeah. I mean, the problems were pretty straightforward, but maybe like G, I lost 30 minutes on G for no apparent reason, and H, 20 minutes on H for no apparent reason as well. Okay, so the first problem, called forces. Just have some string called forces and compare if the letters are different, we just want to count plus plus. Pretty straightforward. The second problem, is finding the longest consecutive sequence of zeros. And this is just, if it's 0, you increment the current sequence. If you find 1, then you have to reset the current sequence, of course, but then just update the longest sequence. And at the end, update the longest sequence like with this, because maybe current is some bigger number. So if there are a lot of zeros at the end, right, without like 1 at the end. This could be avoided by just maybe pushing one more element, plus 1 here or something, then don't read in that element, but it's just like, it's enough. Okay. C, also quite a simple problem. So the trick is just brute force. So this is nothing. Although, like, if this is like a maximum coverage or something, if it's like n bits here, you want like maximum cost, like not exact cover, but you want, it doesn't matter. So what you do is, like, if you find 1 1, you want to update the time, the whole time. If you find the first one, you want to update some t1 variable, t2 variable for the second time. If you just find like the second book here, and then the time will be minimized by the sum of these two. Maybe the sum is minimal, and then if time is like very big number here, what we did here with the maximum, or just like 10 to the 9 or something like that, crazy big. If it's like very big numbers, is -1, just that's like the infinite. So I don't have to like write many edge cases. This was the idea here. E, I did not, but wait, did we get Gold Rush? Okay, D. Okay, so the D was like, I don't know how you're supposed to solve it otherwise. What I saw here is like, any number can be written with the prime factorization. So some number, let's say n, can be written by some prime factorization, p to 2 to the power of some power here, times 3 to the some other power, times 5 to some other power, times like that. These powers, of course, can be 0, and if power is 0, this is just 1. It doesn't, maybe it's not here. So what we want is, like, if we prime factorize n and m, but we don't have to prime factorize it the whole way. We just care about the powers here on 2 and 3. Why? Because like what I actually did is disk power, I called it here N2, N3. So let's just like do this N2, N3. This here is like M2 times 3 to the M3. And here I will say times some other thing here. Times some, let's say, not D, let's say D or whatever. Okay, and now why I want to do this? Because if I have like if I have some integer, let's say this is some A integer, what I want to do is, what I can do is divide this integer such that like this is A divided by 3, and this is A divided by 3, and this is A divided by 3. So this pile has 2 times A divided by 3, and this pile has 1 times A divided by 3. So we essentially converted integer A into some integer where this integer has a power of like of the 3, so 1/3 like less, and this here integer has 1/3 less, so 1/3 here less. So this here integer, let's call this whole thing is pile 2, or maybe not p2, like I don't know, this is like 2 times A divided by 3. What does it mean? It means that you have 1/3 less but 1/2 more. So essentially what I can do, what this observation tells me is that I can take some here in n, because we start with n and we want to end up at m. So what this tells me is that I can take something from here and I can either like delete it, some 3, like I can take some 3 and delete it, or I can take some 3 here and convert it to 2 and delete it. So what I can do is like n3 minus minus, or I can do n3 minus minus m2 plus plus. These are 2 states by just making this like how do you say it, splitting this into two piles, right? But in no way I can, whatever I do, I have at the end to remain like this. This here and this here has to be equal. So I can only modify this by the operation. I cannot modify like the remainder of the prime factorization. So what I do is like I prime factorize it through here, 2 and 3, and then I check if these here, the remainders, are equal. So what I do is like I prime factorize 3, 2, and 3, 2 for the n and m cases, and then if the remainder is not equal, or we have like 2 cases here where like what you can't do, so you can't have like m3 bigger than m2, because m3 can never be increased. 3 can never be increased. 3 can be only decreased, and also m2 can never be like smaller than n2, because only can be increased in this case. That's why it's no. And then the difference between these values have to be equal to the difference between these 2 values, and that's when it's yes. Otherwise, no. So that's pretty much it. Took me a bit. Okay, let's go E. Okay, so E is just straightforward DFS, like or whatever you do, like DFS or maybe DSU or something, whatever. Like it doesn't really matter. The only thing it matters is just like you cannot start at like 0. So for some reason I had like this missed, but you can start anywhere with like bigger depth than 0, and then you just traverse with BFS, like all of the squares which have bigger than 0 and are adjacent and have like bigger than 0, and just push them in the queue. And all the time you do the same thing. I'm using this direction from 0 to 4, from 0 to 3, actually. Like, this direction is actually like deltas. So how do you move it in the x direction, and how do you move in the y direction? This is to help me really easily just like avoids ifs. It's like it does it with a for loop, and then you have to check if that new thing is valid, if like you didn't go over the board. And okay, if it's valid, it's not visited, make it visited and pushed in the queue. When the queue is when something is visited, just sum up something, and then this component we just want like the sum of like components, and you maximize your answer with the sum of each component. So you want to find the maximum sum possible. So that's pretty straightforward. F is also I don't know what's the initial, like, this problem could have been like a lot harder, but the thing is, like, if this graph wasn't just connect x new vertices to the central and connect y new vertices to the each of x vertices, if it would be like you could do this operation as many times as possible, this could have been a better problem, I would say. Like, do this operation as many times as possible. Now, then the problem will be a lot harder. Now, what I noticed here, if you start at any leaf node and you go one step, you always find the y node. And then from the y node, you don't want to go to leaf nodes, you want to go to some other node that is not a leaf node. And this is what I do. I have this degrees of every node, how many nodes have in the neighborhood, right? And then you go for each node, and if the degree is 1, so it's a leaf node, so it's only one connection, then you move to that one connection and you find that y is the actual this node here, let's say. And then you traverse through all of the neighbors of the y node, and you say, okay, if that degree is not a leaf node, if that neighbor is not a leaf node, then you just remember that degree and break. And this here is like, the complexity is like only n. It can't be more than n. It's just, you do it once. But if that problem would be like, you could do it many times, like this operation many times, then what you want to do is like, somehow map out you will have two different sets of degrees. Some nodes will have many nodes will have the degree will be leaves. Many nodes will have some other degree, and many other nodes will have some third degree. So there will be like 3 different possible degrees, and then you want to say that, okay, these nodes that are leaves, I will just pour them out, and then the other degrees are the answers. But okay, this is like just more complicated version of this problem, let's say. This hits different. I didn't like the problem that much, because like, not only that it's I mean, yeah, it's a good problem, but it's brute force. You can easily overflow things. I don't know. I mean, yes, you can solve it with like long logs, but you would have like edge cases and stuff. But if it's only like brute force, I don't know. It's kind of weird, no? It took me a while to like fix all of these longs and things here and some vectors. So what you do is you generate this table here, and what I do is to each node here, I remember what is the prefix sum here from the start to that node, and I do this for every node. And then what you have to observe is that if you're in some position, and let's say you have like, let's say this is 2, right? 0, 1, 2. And then you're here in this 9 squared, right? What will happen is on the next level up, what will happen is that the left pointer, let's say you have like some interval that you're summing up all the time. The left pointer will go a little bit to the left, so L minus minus. but the right pointer will stay until it will like hit a wall where the right pointer it has to be like minimized to the level that size, and that's what I do. I start where that number is. I find that number, where it is, on what level and in what position it is, and then I say, okay, L and R are like the same here. And well, I say, okay, while this level is bigger than 0, so while you can go up, you minimize R first by the length of the level, then you sum up where that interval is, and then you just go L minus minus, and then you do this. You do this and level minus minus. So this is left and this is level. So there are two different things. And the sum is just like, and here I convert it to long because the trick is like this int 128. You can use int 128, but you cannot like print it out. And yeah, I've overwrote LL with int 128, which I never do. Like many times I do this, so I know the difference. I mean, yeah, sure, it's okay. I mean, and then here this H problem could have been a lot worse, a lot more difficult, but okay, whatever. So the trick here is that if I want the end position, if I apply AND operation, the only thing it can happen either the bits will remain the same, so the same number, or this number will get smaller. But the trick here is that just 6, like you can have at most 6 bits, and every number is like to 64. And to 63. So this actually allows for n times 64 approach. Because n is, okay, it's big enough, but 64 is like just constant. You can just, it doesn't push the time limit that far. And what you do is first, for each position I have like dpin, which says if I'm in this position and I take this string, I have taken some number that as my last number in some subsequence to this position, how many such subsequences do exist? And in the 0th position, there is only one subsequence that ends at this number, A0, right? The first number. Then for all of the other next positions, we will copy out the DP table, but what we'll be doing is like, okay, now we can start a new subsequence that starts in this number. Or what we can do is we can go through each of these previous things, let's say, like previous possible values, and we can bitwise add to A1, AI. And then this will be like, okay, if you would imagine like this, if I have AI to be equal to some number, and I iterate over all possible numbers from the previous position, so previous position is here, and if I have like some position like this, and if I take this position as my previous subsequence, and I add AI to the end of it, we get some other things. So like let's say that this bit is on here. We get some like end of this. So this is 1. Let's say this is 0. Then this is 0. This is 1. 0 0 0 1 0 0. So in this. Now this is my end. So the dp of I k or whatever. No, it's not really k. It's like h or whatever. I don't know. It's the number of subsequences having bitwise and equal to h till the index I in the array. This is our TP. It's pretty straightforward, I would say. Oh, I thought doing something. I thought that I needed to do some convolution with like the sum over subsets DP, but no. I thought that my complexity would be 64 times 64, which I thought that I need to optimize to like 6 times 64 or something like that, but that's not the case. And yeah, that's pretty much it. Thank you guys so much for watching, and I see you in the next one.